So today we are going to discuss double replacement reactions. And looking at our help sheet, we have 6 different double replacement reaction types. Of the 6, 5 of them are dealing with acids. Now, once again, how do we identify an acid? It starts with hydrogen. Okay? Most that start with hydrogen are acids. Now, the toughest one of these, in my opinion, is the very first one dealing with the aqueous salts. And that is because when we're dealing with these 2 aqueous salts, we have to follow certain rules. So let's go ahead and let's look at our packet. Okay, let's look at our outline to see and go through the rules. Steps A through E. Step A says determine both possible products, swap the cations. Step B says to check the solubility of both possible products. Step C says if both products are soluble, then no reaction. So if both products read soluble on your solubility chart, no reaction will occur. At least one reactant must be soluble and aqueous to have a reaction. Use appropriate symbols. Parentheses S for a solid. Parentheses AQ for aqueous. An up arrow means that that is a gas that is given off. A down arrow means that that is a precipitate. So you could potentially label it as a solid, or you could potentially use a down arrow to label as a precipitate. But those steps must be followed when we are dealing with 2 aqueous salts. So we're going to start off working a couple of those. So here is the very first one. Strontium acetate reacts with calcium chromate. I'm going to go through and write down what I'm dealing with. Strontium is a 2+ charge. I guess I can put it down a little bit more. Strontium is a 2+ charge. Acetate is a 1-. So there is my strontium acetate. Calcium chromate. Chromate's CrO for 2-. So there is my 2 reactants. Now, my very first step tells me to determine what my products will be. And all I'm going to do is I'm going to swap my 2 cations. So I'm going to switch my strontium and my calcium. Now I'm not going to have enough room on the board, so I'm going to do it under here. So if I swap, I'm going to get calcium acetate and I'm going to get strontium chromate. I don't like that R. Strontium chromate. Now my next step, after I have swapped those, I need to determine my solubility of both of those products. So here is my solubility chart. As I am looking, the first one was what? Calcium acetate, right? Calcium acetate right there. My second one was strontium chromate, right? Strontium chromate. Now make sure, that brings up a good point that I often see. One of the things I often see with this, folks, is people check the reactants, not the products. Okay? We are checking the products to see the solubility. So chromate is 1, 2, 3, 4, the fifth one over. So strontium 1, 2, 3, 4, the fifth one over. So this gives me an S and it gives me an I. Would you agree? All right. So what does an S and an I mean? I come back up to my solubility chart, which you have. S is soluble. SS is slightly soluble. I is insoluble. DR means that it decomposes / reacts in water. And a question mark means that there's no information available or that does not exist. So, by rule, we need to have one that is soluble, one that is insoluble, correct? Do I have that in this example? Yes, I do, don't I? So will this reaction occur? Absolutely. Now, I'm not finished because I have to signify which one is an aqueous solution, which one is soluble, and I have to list which one is the precipitate. So if I remember right, that one, I can put the down arrow because the strontium chromate was the insoluble one, correct? So that is the precipitate. The calcium acetate was the soluble one, so that's the one that is an aqueous solution. Okay? And all aqueous solution means, again, to review, is that it is soluble in water. Now, am I done? What else should I check before I finish? Make sure it's balanced. Is this a balanced chemical equation? I believe so. I believe so. Well, I guess we're working up here. Here is number 2. And once again, I look and I say, okay, I have 2 salts. 2 salts. And remember, I guess I should have started out with this. A salt is simply classified as something that is ionically bonded, a metal and a nonmetal, or a metal and polyatomics. Okay? Rubidium bromide reacts with silver fluoride. I go ahead and I'm going to write out my formulas. Rubidium, it's not one that I'm very familiar with, but I think it's RB. Where is it at? Rubidium, okay, it's a +1. All right. So rubidium is a +1. So rubidium RB BR. Kind of crazy. And silver fluoride. So, what are my potential products for this reaction? Silver bromide, AgBr, and rubidium fluoride. Yeah, John? No. The order of the products or the order of the reactants do not matter. Okay? They do not matter. Good question. Now, I am going to now be looking for silver bromide, rubidium fluoride on my solubility chart. So, fluoride is this column right here. So what is it? Silver fluoride or rubidium? Yep. Which one? Rubidium. So 1, 2, 3, 4, 5, 6. Is this it right here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that is soluble. Right? Okay. The other one is silver bromide. And I'm guessing it's one of these two right here. Bromide's the second column. So silver bromide is an I. So will this reaction proceed? Is it good to go? Yeah, I've followed my rules. I've got an insoluble and I've got a soluble. My insoluble is going to be the silver bromide. Okay, so down arrow, my soluble one is the rubidium fluoride. I look back through. Do I need to balance anything? I'm good to go. It is balanced. Here is my third example of two salts. Sodium phosphate will react with silver nitrate. So, I flop my cations, and I'm going to get sodium nitrate and silver phosphate. Would we agree? Once again, my solubility chart. Sodium nitrate, I'm almost certain, is soluble, just by remembering that. Silver phosphate. Sodium nitrate. Where's sodium? So sodium nitrate right here is soluble. Silver phosphate. Phosphate's the fourth one over. Silver phosphate, 1, 2, 3, 4, is insoluble. So I meet my parameters. So I know that this one is my precipitate, and this one is aqueous. Is this a balanced chemical equation? It is not, is it? So I look and I say, what is going to be my problem? I look and I see, first of all, that my silvers and my sodiums are not balanced. So I'm going to put a 3 here. That balances up my silver. I put a 3 here. That balances up my sodium and my nitrates. So now do I have a balanced chemical equation? Absolutely. Absolutely. Now, let's go back and look at something here. Let's say I would have came upon, and I don't care what it is, but that a lowercase s means that that is slightly soluble. Okay? If something is slightly soluble, what would you think about the other way? If it's a little bit soluble, is it a good amount insoluble? Okay? So if you have something that is slightly soluble or a good amount insoluble and something that is aqueous, that'll work out. Okay? That'll work out. If you get something that is DR, it decomposes. Well, in order to decompose, does it have to react? Yes. Okay? Yes, it does. Yes, it does. Now, we've dealt with the first part. We dealt with the first part, double replacement number 1, 2 aqueous salts. Let's get into some of the second ones, and the third one, and the fourth one, and the fifth one, and the sixth one. Here I have calcium carbonate reacting with hydrochloric acid. Now, as I look at my different tools that I have, what type of a reaction is this? Decomposition number what? Decomposition number what? Which one would you anticipate this one to be? Obviously, we have an acid. What's it paired with? Decomposition number 3. Because we have a metal carbonate or a bicarbonate. What's a bicarbonate? What's a bicarbonate? What's the difference between a metal carbonate and a metal bicarbonate? Okay. In order to answer that question, you would need to look at your PAL. Okay? If you look at PAL, check out the difference between a carbonate, which is CO3, and a bicarbonate, which is HCO3. But what's bicarbonate's charge? It's a -1. Okay? So, as I am looking up here, calcium carbonate reacts with hydrochloric acid. I'm going to be dealing with a double replacement number 1, which gives me a salt, it gives me water, and it gives me carbon dioxide gas. Well, my salt is just going to be what happens when I swap my cations, my H and my Ca. So, excuse me, my salt is going to be calcium chloride. Calcium's a 2+, chlorine is a 1-, so I need 2 chlorines. Also, they told me water, my help sheet did, and also my help sheet told me carbon dioxide gas. So I have 3 products here. As I am viewing this, calciums are balanced. I can't keep my carbonates together, but I look like I have CO3 over there. I need a hydrogen and I need a chlorine, right? So if I put a 2 there, I'm saying that this is a balanced chemical equation. Silver bromide, ammonium sulfate. Now, let's skip this one here first. Let's go to number 3 because I think this is another acid one. I'm going to let you do that other one on your own, and then we're going to go over it. This is lead 2 hydroxide plus hydrobromic acid. What type of a reaction is this? Decomposition 1 through 6. Which one is it? Decomp 1 through 6. Which one is this guy? Anyone? Number 4. An acid and a base, a metal hydroxide, yields a salt and water. This, ladies and gents, this is a special type of a double replacement reaction. We call it a neutralization reaction, in which an acid neutralizes a base or vice versa. Okay? So, this is a special reaction, a special double replacement. We will deal with this guy in depth when we talk about acids and bases, either 3rd or 4th 9 weeks. So, lead 2 hydroxide, PbOH2, plus hydrobromic acid yields a salt and water. Well, my salt's going to be lead bromide. Now, just a little teaching point right here. Do I want to switch this lead right here to lead 4? If I have lead 2 here, let's make sure that over here I have lead 2 also. Okay? Let's not switch the oxidation state of that lead here. So I've got lead 2 bromide, and water. Do I have a balanced equation? Obviously not. What do you think my problem's gonna be? Okay, what's the problem balancing? Well, number one, I see bromines are off, and this OH is gonna cause me some problems. So I'm just gonna flop in. If I put a 2 here, that balances up my bromines. Then that gives me 4 hydrogens and 2 oxygens. And I believe if I put a 2 here, I can balance those up. So as I do so, I come up with a balanced chemical equation. Okay? Now, what I would like for you to do is I want you to take a shot at this guy right here. Okay? Do the double replacement right here. If you run into a problem, raise your hand. I'll come around and walk you through it. Okay? First of all, let's go with the AgBr. Let's go with the ammonium sulfate. When I swap my cations, I'm going to get ammonium bromide and silver sulfate. I check my solubility chart, and on my solubility chart, ammonium bromide up at the top is soluble. Silver sulfate is SS, slightly soluble. So what do you think? What do you think? I think yes, too. So I need to put my down arrow there. I need to put my aqueous here. And now I need to balance. Looks to me like a 2 and a 2. We'll balance this up. Now, what I would like for you to do is you have a worksheet in your packet that deals with 10 double replacement reactions. That will be due tomorrow. We'll half sheet scrap it. So you have the rest of this period to do so.